Thanks for coming back. That's the third and last part of our presentation for today. After that, we're going to the meetup. And that talk is a bit different. So we struggled with the name, actually. So we came up with this 101 quadruple O. And what does it mean anyway? So we thought it would be one-on-one on Pebble development, but 10,000 times more awesome. Or, I mean, as I said earlier, it's, I mean, that's in hex 5.0 or the capital P. And actually, to be honest, we couldn't come up with something meaningful for that talk here. What we are about to do, so when Matt and I prepared that session, we figured that whenever we met developers who haven't talked to us before, they were surprised what kind of tooling we are using or which libraries we had. I mean, did you know about APNG before? Certainly not. And so also the kind of tooling we are using in the first place. So that one here is intended to be looking over our shoulders. We are showing you some tools we are using, some workflows we are following, and then also libraries we use. Catherine, the main organizer, reminded me that we should finish before the next full hour. Since my Pebble is already under camera, I cannot see. I think we have half an hour?
Yep.
40 minutes. 40 minutes, then questions and live demos, you know, they always go bad. So we rush over that. We might not, so we can do that as an open end. But basically, I want to remind you that we have the whole weekend to work together. When you have questions, when you want to see something awesome or have particular questions about tooling or anything, Matt and I, as well as all the other Pebblers, are here the whole weekend. Grab them, talk to them, let them show you what you are interested in. And also, demos like these, like, hey, look what I just did, or look how I am doing that, this is happening tonight at the meetup as well. So I'm highly encouraging you to show what you are doing, what kind of tools you are doing, and to ask Thomas, if you can. Thomas, can you raise your hand once more? There he is. Grab him and ask him for a slot so you can present tonight what you are working on. So that is the last real slide we have. Let's go and do some live hacking. So one thing I really missed when I started Pebble development was real tooling. So I'm not sure, what kind of editor do you use when you develop? Who uses Vim? Whew. Oh, that's half of the audience. Who does use any other text editor without any IDE features? That's the other half, more or less. So who uses a real IDE? Which is something like Eclipse, maybe, or Xcode. Who uses Xcode? That's 3 or 4. Who uses Eclipse? That's 7 maybe. What? Who uses AppCode? 1. Okay. So I'm using AppCode. And
oh, you missed one. Who uses Cloud Pebble?
Sorry! That is, I think, let's compare that. Who uses Vim and Cloud Pebble? Okay, so Cloud Pebble wins here. So yeah, I am, and that's awesome. That tool is just awesome. Personally, I am tied to my IDEs, my native IDEs, and I was missing something. So what I came up with is PebbleX. So when you see that here, can you read that from behind? Is it large enough? Can go to the top maybe? Okay. So when you create a new Pebble project with a Pebble command, and you say new project, and I call this def retreat. That folder structure usually looks empty, right? I mean, you have nothing here, and all you can do is then from the command line call Pebble build, and you have your application. What I wanted to have is a Xcode or AppCode integration. So when you look at the RubyGem directory, you will find a tool called PebbleX, where you can, among other things, create an Xcode project. And that one you can open then with, say, AppCode in order to have full IDE support on Pebble development. So when you open then the def retreat C file, you will not only have syntax highlighting, but also you can navigate to the code, or you can see who calls that code in the first place and jump back. Or when you have, say, here the load handler, and maybe we do, say, the click handler here, you can print the whole call tree, who calls that from where, and I mean, things like a real IDE does. And then it goes further. What we cannot do, since Pebble doesn't, the Pebble command doesn't support that for now, is running that application. Well, yes, it can run the application, but it has to know the phone. So here on my desk is the actual phone, and I'm looking up, as you are used to that, the IP address of my phone. All the cloud pebblers don't have to do that, since it's super cool how it's implemented and does it automatically, but all the others have to type that in. You see there's an arrow here. Whoops, I just created that project. Yeah, well, actually, we do not return something. So while the GCC doesn't complain, it's certainly bad habit to not return anything here. Okay, so I hit now play on my IDE. It calls the Pebble command, it runs it, and deploys it on my phone, and now it's on my watch. Well, is it, isn't it? Yes, you cannot see my watch. I will bring up the camera. Now here's the camera. And so that's the live image, and you see down here the button presses. You also see the log output. So whenever I close that application and go back into the application, where is it? Def retreat, I'm back. You see the log statements here. We do not support debugging, but at least you have real logging here, can jump to the files and do all the navigation stuff. When we go to other examples, I will show you what that IDE actually can do. There was a question about the performance of the frame buffer routine. Who asked that? How fast it was, and I said, there you are. What's your name again? Pardon? Ron. Okay, Ron. Ah, yeah, Ron. No. I'm looking forward to your talk. So let's open that. I am opening the, it's still open, I think, the frame buffer, feature frame buffer. That example you saw during the demo will be part of the SDK's examples. So let me bring up the camera, it's there, and then I am running compile that. So here it is. I changed it a bit. So you can see that, let's look for update procs. We have the frame buffer update proc, and it calls the method feedback, and I just commented out that string. Now I'm doing that, re-enabling that, redeploy that right from the IDE. It stops and runs again. So now you can see which method it uses. Granted, it's a bit dark here, but I mean, you see it runs fluently, right? Now the question is, how fast does it actually go? Again, I'm calling here IDE, where am I called from? I have the draw pixel, I have the frame buffer, I will call that one here. Now, a simple way to see how fast it actually is to redraw it. Per update, actually draw it, say, 10 times, right? So in order to do that, I'm now extracting a function. So I'm not releasing the frame buffer, I'm really doing just the drawing here. I asked the IDE to create me a function, do the stuff. It automatically knows that the frame buffer goes into it, it puts it above it, and that's it. It's now extracted. As you can see, it's there. And then now I put a for loop around it, say 10 times, move that up, and here I am. Now, for each update, it now does 10 updates. When it runs smoothly at 30 FPS, it now runs smoothly at 300 FPS. Okay? Maybe just to be sure, I comment out that one here, so you see there's a difference. Let me increase that number once more. So gnome painting, 30 times 3900 times per second. And you still see it run smoothly. I haven't tried how fast it actually goes. Let me, what do you think? 500? And it's not the most scientific way to measure the performance, but at least we see some results. So, and always, I'm not leaving the IDE here. You saw the refactorings and anything and navigation. Again, it's a real IDE, and it works with different files as well. Also, there's an error on deployment, the phone says, for whatever reason. Oh yeah, then you see some lag. Okay, so it's not capable of drawing 1,500 frames per second, But somewhere below, I think you can achieve a gradient with the frame buffer axis. Okay, so this is what I want to tell you here. It's, you can use Xcode, AppCode, or other IDEs and do Pebble development with all the comfort you have with, refactorings. Let's say I'm just renaming that function here to some other name, and it will be renamed everywhere, even in code comments. Sorry, I missed the click the right button here, but I think you get the idea. Since we are short on time, I'm going over to the next one, which is how do I explore visuals? So when I was doing that Boing Ball example, I had to struggle with all the math, right? How do I render that? How does it look like? And then whenever you do that in C without debugging capabilities, that's a tough game. So what I did instead is I wrote it in Python. So I'm not saying that we have a Python cross-compiler, but for exploration, it's good enough. So let me show you that. Here, super ugly code, copy and paste it, and you might remember that one here. All that stuff that might look good like or might not look good like, this is just the code. And if I run that, so let me open that Finder window here, and I'm now running that Python script, boom, it's done. It creates that file here. So let me change that. I extracted already some parameters, and now it renders something with shadow. Let me deal with that numbers. Oh, that looks good. So I can tweak numbers. I can easily tweak methods or anything. Here, for example, we have, I just tested how to do with floats, how to do a gradient, and how does it look like. Well, that doesn't exactly look like the Pebble. So what I did instead, in the end, is I did that with the very same algorithm I had before, just to see, well, how much ambient light do you actually need in order to make that good light? Or, doesn't it look better when the light comes from the left? Let's remove that one here. Oh yeah, that's cool. And then recently I played with textured floor. Can't we just make that perspective? And yes, it would be even better if we had shadow. And yeah, yes, granted, I'm just commenting out file lines here, but in the end, we have a real debugger. We can have breakpoints at any point. So I'm running here now a debugger. I can look at all the values, debug them, and continue until what's achieved is what it should look like. And then in the end, I port that over to C. I can even go that far and change my Python code in order to look more like C before I actually port it over. I do that regularly for different things, and I have the feeling that I save a lot of time. Now, having that as a screenshot alone doesn't really cut it, right? I cannot say if that dithering is perceivable on the watch or not. So a friend of mine, Marcel, who is sitting there in the corner, wrote a tool called Pebble Mirror or Pebble Preview or whatever. And the idea is it Pebble Mirror or Preview?
Well, I have to change it to
Okay. It's now beep mirror. Okay. So the idea is that you have an app. Oh, sorry, you cannot see that at all. You have an app on your Pebble, which displays what you have here on the browser. So whenever you have a file, say that one here, you can drag it to that window. Whoop, you drag it over, and then it dithers, so that was transparent, and transfers it to the Pebble. And that's a real thing here. So now you can look at it and see, well, do I see the patterns? Does it have to be lighter or darker? And I can, again, go to Python, optimize that, and upload it quickly. And it goes that far that you can even use the clipboard with that. So what I constantly do is not using Python, but also Photoshop for things. Let's open that one here. Yes, for that what I'm going to display is way overkill, but assuming you are doing something in Photoshop, and say you want to do that, and you want to invert the colors, right? I can now copy that into my clipboard, go to the browser, paste it there, and it will be automatically transferred to your Pebble, so you can see the actual result. And yeah, there it is. So you can see, well, how does that look like? And the workflow actually is you tweak with your pixels and paste it over in the browser and constantly have your Pebble open to see the result. And this is just, that's yet another tool to support the workflow, but for me, it's a tremendous time saver. So I think I'm through with all my tools. When we look at the time, yeah, we have to
3:40?
hurry up. So do you want to see something on the Pebble before?
I've got Ken videos. I'll use those.
Okay, cool. So I'm now pulling my Mac, and we plug in a Linux laptop. Let's see how that turns out.
All right. Thank you. Oh, come on. We have a display.
Yeah, great.
And we have the same display. All right. Problem one. So I just really quickly wanted to talk about how I work with PebbleGL and when I'm basically working on more advanced tooling or systems. So PebbleGL is kind of a neat example in that it's a combination of a bunch of the things we were talking about, the fast math, the direct frame buffer access, and 2D drawing. So if I go in here into the source, I can see here I've got a main C file, that's my main entry point. I've got this model STL. This one's actually the PebbleGL rendering 3D models, which I'll show a video of in a second. And I've got this mini GL folder. I'm just going to quickly go in there. And in here we see a couple interesting things. We see draw 2D. Because we're drawing to the frame buffer, I can't use graphics draw pixel or graphics draw line. So what I have here is I actually have a wrapper around the frame buffer drawing. And that wrapper provides pre-dithered functionality. So I can draw a line, draw a pixel, or draw a dithered line or a dithered rectangle. On top of that, I put mini GL. My openGL engine wants to draw everything as triangles, lines, and points, but it wants to use shades of gray. It wants some depths. Like, we actually want to be able to use lighting sources and bounce off pixels and see something other than just black and white, like just a silhouette. And then finally, in here for performance reasons, we have this math SLL, the fixed point math wrappers we were talking about earlier. Part of that's necessity. PebbleGL doesn't fit on the Pebble without that. Between the direct frame buffer access, the mathematics, and just like the entire code base, it's more than 24K, plus the models. And, but with that, we can fit in. And then this little extra LLVM extend. This one, I have kind of a special case where my STL models I want to render, they're actually like MakerBot models that you can print on 3D printers. The model format actually comes in float. My fixed point library only understands its own representation, SLL. I need some way of converting between floating point and SLL, but I don't want to rely on the soft float library that's going to pull in more than I want. So this LLVM extends FDF2. It's going to allow me to convert from float to double, but it's totally self-contained. It actually comes from the LLVM project. It's a BSD licensed library. So those are all the pieces kind of in conjunction. But when I'm actually developing, a lot of times it's a lot of effort going between the computer and the watch for debugging. And like Heiko said, he has some methods of developing on his desktop in terms of images and graphical rendering. For me, I said, well, PebbleGL is going to render to the frame buffer, and it's a software renderer, so why don't I just give it a frame buffer on my desktop? So I wrote a very small shim called SDL test, and it's just one C file. And all it's doing is basically creating a window on the desktop, creating a frame buffer, has a method of passing, getting keyboard events, so I have key up, key down, key select, so I can kind of match the functionality of the Pebble buttons. And then when I build this, I can run on here, and this is my STL model render on the desktop, so I can actually run through the code. I can run GDB directly on it, and I can see if any of my software math, software rendering, or these other things have issues. So I can do all of my development locally. And since I have the buttons mapped, I can also switch between different modes. And obviously, this is linearly scaled. SDL doesn't have a better scaling algorithm than linear. So that's why it's so pixelated on here. So I'm going to show that same thing that was running on the Pebble earlier. Let's try again. That's really dark, isn't it? Can you guys see that at all, or is it just too dark? Okay. I think we have brightness. There we go. So you can see here we're rendering some 3D models on the Pebble. We've got a lighting source. STL models don't have any concept of color. It's just vertices and points, because we're going to print it on a 3D printer. So what we do is we actually set a lighting source in openGL that bounces off every pixel when we're filling them in. When in wireframe, we don't have the overhead. But because it's bouncing off, it's going to need different brightnesses or different colors. So once again, we're applying Heiko's ordered dithering so that we can get those shades of gray, so we can actually have some depth in the application. Let me just, so you can see here the giant robot or the unicorn. You can see as it rotates, you actually have the shadow effect when the light's not hitting directly straight on. So the nice thing here is that the wired mode, the wireframe mode, gets about 25 to 30 frames a second. It's very quick. The filled mode, the gradient filled mode is a little bit slower because we're actually bouncing that light off every pixel, and we're doing all the computation in fixed point. So one of our awesome interns on Monday basically asked if he could use my openGL engine to write something kind of fun. And after seeing Heiko's demo, he's like, what would that look like in openGL on the Pebble? And he's back there, Ben Hudson. Thanks again, that was awesome. He got running in a couple hours. It was totally great. So we're going to run it on here. He finished it last night at 2 in the morning. That's mine. So you can see here, this is openGL. He's basically, there's no lighting source in this case. In this case, he's basically drawing the sphere, and then each different quadrant in each section, he's using a different color of gray. I can just click play on that again. And it looks pretty good. We could tell it's not quite as nice as Heiko's. Like, that was a very polished bowling ball. But in terms of a quick openGL port, it was pretty neat. And then finally, I've been working on developing a simple OpenGL racing game. I'm only like 10% in. So right now it's just a tech demo. But for me, I wanted to apply some modern API, OpenGL, to make everything very easy. I can rotate, I can scale, I can translate. And I wanted to apply it to a 1989 game called Stun Runner from my youth that I really loved. So I'm going to first just play the video of that. GL Racer. Oh. So you can see here it's got the tunnel effect. We're doing the different colors on the bottom. I've got a spaceship with a shadow, and then I've got a wireframe on the top. That's pretty much as far as I've gotten with that app so far. One of the things I found very early on is my 3D model renderer that was rendering the MakerBot models didn't do perspective. Basically, no matter how close or far something was from the viewer, it was the same size. So it could be 100 miles away, and it would still be literally this giant ball on the screen. So for the perspective engine, it's like a railway tunnel. It actually needs to get smaller in the distance. So I took a couple hours reworking the PebbleGL to now handle perspective. So it's very much an older version of OpenGL. It's more like OpenGL 1.2, where you say like rotate, translate, scale, position, and then you draw your triangles or you draw your your polygons. And then just the last piece of this. So I'm going to go into GL Racer. I'm going to go into the source code. And when we're talking about tooling, one of the nice things is that, so I do all my development on Linux with Vim, because real men use make. And there's a nice plugin called uCompleteMe for Vim, which lets me do auto-completion. So I can do, it's not working.
You name code completion, right?
Yeah, code completion, yeah. Okay. So here, I'm just going to run the simulator one more time. So once again, we can see that shim. So I can actually test my application on my desktop. I can do button mapping. But this is really nice for me where, in the end, the application is going to look the same on the Pebble or on the computer, but it's much more familiar and fast to just compile, look at it, make a change, and keep iterating. Great, that's it for my part.
Okay.